Okay, all right. So we're going to look at doing transformations on data that's nonlinear. If we look at this, we're mapping um, x to y, which is basically these are lengths of lobsters, and these are their ages. So we are kind of linking these together. You could make a line for it, but you can see that the data tends to kind of want to curve up, seems to follow a curve a little bit better. Um, so this would be if you plotted this out on a scatter plot, what your data would look like. So we want to look and say, like, well, what is it that we can do to linearize this data to make it more normal? Well, we go through this process of transformations. So let me look at this next page here. If your data is looks in a particular way, there's certain things that you can do in order to fix it. And it's all based on this chart here. Use these 4 different quadrants as kind of an example. If your graph looks like this, where your curve is kind of dropping down, then there's certain things you're going to want to do to it. You can either ramp up your x or ramp up your y. Either way, you can fix your data. So when it means ramp it up, that means that you're going to be going up the list from where you are originally. So normally you're at your original value, power of 1. So if you were going up, you might want to square your data, or cube your data. Now, if you had a different scenario, so let's say your curve looked like this, where it was kind of plateauing as you go along. This might be something to where you'd want to either ramp down your x or ramp up your y. So the y you may spring up, but the x you might bring down. So this could be something that you could do to fix your data in that regard. Finally, you'd have data that looks like this, where you're either kind of plummeting or you're accelerating up. These 2 things, you just have to read this chart. It's on the back side of your concept sheet. So what we want to do here is we are going to look back at our data. Our data seems to have an upward curve to it. So we need to find which quadrant are we in. So it looks the most like this one down here, the second. That tells us that we can do a few things. We can either ramp up our x, or we can ramp down our y. So if we think about ramping up or down, we could square our x or square root our y and basically get a little bit better looking data. So give me 1 second and we will look at how to do that on our calculator. Okay, so this is our list here. Yours might look a little bit different than mine, but as you go down the list, you can see all the data points are the same. This is obviously my y, this is your x. You'll probably have them in list 1 or list 2 in different places, but that's okay. So what I'm going to do is I'm going to call this column, I'm going to call this the square root of x. Because again, I'm trying to ramp down my my x's. So I need to do that. So this is going to be the square root of x. Oops. Or we'll call this sqrtx. And so sqrtx, what this is going to be is this is going to be the square root of x. Or b, which I will say, which you all will use the square root of whatever the list 1 or list 2. Okay, so I go through and I populate my list and I get all of my points there. So this is great. So let me go back to my graph. Now, instead of graphing it against x like I'm doing here, I'm graphing it against the square root of x. So this kind of is going to flatten my data a little bit more than it was before. It's not a whole lot better. I mean, you can see that it does shift away a little bit, but should help flatten it a little bit. Now I can also do the same thing for y. I could even play with y a little bit more. You know, if this one I wanted to do this like y squared, in order to pump it up a little bit more, we're going to go here and say that this is going to be the square root of a. Oh, oops, that is not what I wanted. I need to do a squared. Apologize. Right. So a squared is in there now, and you can see that we're judging this versus that. These are squared versions of the same numbers. So we're going to go back to our plot. And so if we change this back to x, you know, we can see that that's going to shift the data a little bit. If we change this to y squared, it seems to flatten this data a little bit. Now it seems like I have one really high point, and that is really far outside of my data range. So maybe a little bit of a mistake there. And then, but I could also go back and change this to the square root of x. And you can see that it's going to change the data depending on how different things work. So what you want to make sure, and this is y versus y squared, that shouldn't do that. What you can see is that we can basically transform data, and as long as we are saying, hey, yeah, we're squaring this or we're leaving this the same, it's fine. And we're going to base that off of this chart here. You know, if our data tends to look one way or the other, this is how we're going to change it. And when you just do that in your list. So when you go back and write and you find a linear transformation for something, you just need to make sure that you're writing the equations the correct way. So you still run your linear regression the same way, but instead of doing x to y, you're doing now x to y squared, or the square root of x to y squared. It still works the same way.